1 minute ago, Mount Etna just erupted, and what it spit out has never been seen before. If you think you understand volcanoes, this discovery will completely shatter everything scientists thought they knew about what's hiding deep inside our planet. Right now, while you're watching this video, Mount Etna is spewing a mysterious glowing material that doesn't match anything in geological records. We're not talking about typical lava or familiar volcanic rock. We're talking about something that appears to have formed deeper inside Earth than any volcano has ever accessed before. The eruption escalated into a violent pyroclastic flow racing at 140 kilometers per hour. But here's what's really strange. It's scorching land that was already barren, suggesting this isn't behaving like any normal volcanic event. Scientists are calling it a paroxysm, a rare, explosive outburst that signals Etna may be entering completely uncharted territory. But when researchers rushed the mysterious material to labs for analysis, what they found made their blood run cold. It wasn't basalt. It wasn't andesite. It wasn't any mineral they'd ever seen before. The composition suggests Etna is now mixing mantle and crustal material from depths that should be impossible to reach. Here's what's keeping volcanologists awake at night. Etna's structure is showing signs of instability that mirror conditions from 7,200 years ago, right before a massive flank collapse triggered a Mediterranean tsunami that reshaped entire coastlines. The question isn't just what this strange substance is. It's whether Mount Etna is trying to warn us about something catastrophic that's building deep beneath our feet. Rising more than 3,300 meters above the Sicilian plain, Mount Etna looms as both a landmark and a warning. Its summit, crowned with shifting craters, is visible for miles, a constant reminder that the ground here is never truly at rest. For centuries, Etna has shaped the fate of eastern Sicily, its slopes carved by rivers of fire and its name woven into ancient myth. UNESCO designated it a World Heritage Site, not just for its beauty, but for its restless spirit and the scientific record it holds in stone. Etna's history is written in layers of ash and lava, each marking a moment of upheaval. Roman chroniclers described nights lit by fountains of flame, while medieval villagers told stories of the mountain's anger swallowing fields and homes. Yet for all its drama, Etna's rhythms have become familiar, a cycle of rumbling unrest, brief eruptions, and long, uneasy calm. Scientists at the Osservatorio Etneo monitor every tremor and plume, mapping the mountain's pulse with seismographs and satellite feeds. They have learned to read its moods, watching for subtle changes that can mean the difference between spectacle and disaster. On February 8, 2025, that familiar pattern began to shift. A swarm of small earthquakes rippled beneath the summit, more frequent and deeper than usual. Instruments picked up a tremor, low and insistent, echoing through chambers far below the surface. The mountain's breathing changed, and with it, a sense of unease settled over the observatory. For those who know Etna best, the message was clear. Something beneath the volcano was stirring, and the old rules might no longer apply. At dawn on February 13th, a team of volcanologists and a helicopter crew prepared for a mission that defied common sense. The summit flanks were already trembling from frequent quakes, but the call came through. A new flow had broken loose, stretching 3 kilometers down the south slope, brighter and denser than anything seen in recent memory. Sensors warned of ash columns rising fast, and aviation alerts snapped to red. Still, the team pressed upward, racing against the mounting instability. The air near the crater was thick with sulfur and heat. Every few minutes, the ground lurched beneath their boots, sending loose rocks skittering toward the valley below. The lead volcanologist signaled for the others to hold back as he edged closer to the source, a glowing, viscous stream pulsing from a fresh vent. With protective gloves and tongs, he scooped a sample into a reinforced canister, the material radiating through the metal like a live ember. Ash blasts rattled the ridge, and the radio crackled with warnings of a possible collapse. Suddenly, a deep tremor sent a wave of debris tumbling downslope. The team scrambled, clutching their prize. Above them, the helicopter hovered, rotors slicing the haze.
The extraction happened in a rush. One by one, they were pulled aboard as the wind suddenly changed, sending waves of ash across the landing zone. Within moments, the mountains erased all traces of their presence. The still warm sample was quickly transported down the mountain and handed over to a secure laboratory team, initiating a chain of custody that would soon capture global scientific interest. At the Katana laboratory, the sample arrived, its heat still seeping through the double-sealed container.
Chain of custody protocol demanded immediate transfer to the isolation chamber, but urgency outpaced caution. A technician in heat-resistant gloves logged the time, 0812, and reached for the reinforced latch. The instant the seal broke, a sharp hiss filled the room, followed by a burst of vapor that shimmered with an unnatural glow. Sensors flashed red. Alarms blared. The containment officer shouted for evacuation as a caustic sting swept through the air. In the confusion, a gloved hand brushed the edge of the vessel. The technician recoiled, clutching a wrist now ringed with a raw, angry welt, evidence of a burn from contact with the unknown substance. Automated shutters slammed down, locking the sample inside negative pressure containment. Emergency protocols triggered a full lab lockdown. Within minutes, the corridor filled with the thud of boots and the clipped voices of hazard response staff. Medical responders hustled the injured technician away, his burns minor, but his shock unmistakable. The officer responsible for the chain of custody barked orders, demanding a full incident log and chemical hazard scan. Outside the sealed doors, senior scientists watched monitors as real-time data flickered across the screens. The material's surface temperature refused to drop, and its vapor cloud defied standard filtration. Every routine analysis failed, leaving only questions. In less than 15 minutes, a routine handoff had spiraled into a crisis. The sample, once a scientific prize, now sat at the center of a biohazard scare. For the team, the message was clear. Whatever had come out of Etna was not just unfamiliar, it was unpredictable, and it would not give up its secrets easily. Remote sensing specialists gathered in makeshift command tents, their screens lit with the latest data from fiber optic cables and seismic arrays. The usual patterns of magma movement were gone. Now, the instruments mapped out a patchwork of silent zones, places where expected signals simply vanished. These so-called muon gaps, detected by cosmic ray tomography, hinted at unexplained voids deep beneath the southeast crater. Theories flew across encrypted channels, hidden magma pockets, collapsed conduits, or something else entirely.
Each new scan only intensified the urgency of the debate, with demands for a denser seismic network growing almost overnight. Beyond the scientific community, the public was closely watching and reacting. Reports soon emerged that 2 mining companies had sent drones to the slopes of Mount Etna, searching for rare elements left behind after the eruption. Their presence sparked widespread outrage as environmental groups called for accountability, accusing corporations of trying to profit from a natural disaster.
The park's UNESCO status became a rallying cry. In Catania, the activist collective Voci dell'Etna organized a march, their banners reading, "Hands off Etna, no to mining in the shadow of the volcano." The demonstration drew hundreds, their chants echoing through the old city streets as officials scrambled to reassure the public that no mining permits would be granted. Within days, the debate spilled over into Parliament. Lawmakers called for an immediate ban on all non-scientific drone flights, while volcanologists pressed for expanded access to deploy new sensor arrays around the crater. The stakes had shifted. Etna was no longer just a scientific puzzle, but a battleground where technology, economics, and public trust collided.
Mount Etna's 2025 eruption has left scientists and the world in shock. For the first time, researchers recovered a glowing substance that doesn't match any known volcanic material. It's neither basalt nor andesite, suggesting something far deeper and more unusual is happening beneath the volcano. The eruption itself was intense, producing fast-moving pyroclastic flows and unusual behavior that doesn't follow typical volcanic patterns. Lab tests failed to identify the material, and even handling it triggered safety concerns, raising fears about its unpredictable nature. At the same time, seismic scans revealed strange voids deep inside the mountain, similar to conditions that led to a massive collapse and tsunami thousands of years ago. This has increased concern that Etna may be entering a dangerous new phase. As scientists race to understand the discovery, public attention has exploded. Reports of companies searching the area for rare elements sparked outrage, turning the situation into a clash between science, profit, and environmental protection. Despite advanced technology and global attention, the truth remains unclear. What caused this mysterious substance and what it means for the future is still unknown, proving that even Earth's most studied volcanoes can still surprise us.